Guys, so actually I'm looking for laptop. I wanted to install Python, but I don't see any laptop. Okay, no problem. So without installing Python, we can make progress. So as yesterday I discussed that Python you can run in two ways. First is local ways, where you have to install the Python locally in your local machine, in your local desktop or laptop. And second approach is by using Colab Notebook. Okay. So in case if you have no laptop, then you can use Colab Notebook. But again, in mobile, you will not feel that much friendly or that much comfortable in using Colab Notebook. So right now, I'm not installing Python in local. Let's use Colab Notebook. Okay. So
Sir,
let's,
I am unable to see your total screen, sir.
okay. You can't see my screen. Ganesh, what about you?
Total.
Can you see my screen?
I am seeing, sir. I am seeing, sir. It is visible, sir.
Let me reshare them. Okay. Can you see now, Vijay?
Yes, it's okay,
Sir.
sir.
Okay. So guys, so yesterday we saw a couple of, it was only an introduction, right? How to run Python, either local way or either remote way using Google Colab Notebook. Okay. So today class, I'm going to start some introduction about Python. What is Python? What is programming language? And why we are learning Python? Something like something background about the Python. Some basic ideas, some basic introduction about Python. Okay. So this is the notes that I have shared in the group. You can open these notes and you can use this note as a reference if you want. Okay. So in this section, in this chapter, we will learn about a couple of things like, for example, operating system. So it will be only background. Okay. So before jumping to real coding, I want to give some background that what is operating system, what is different programming language, like that. So first I will start about what is operating system and what is programming language, then different types of programming language. And in Python, what are the different software you want to require? For example, compiler, interpreter, IDE, and what is compiler, what is interpreter, what is Python virtual machine, and Python is an interpreted language. What is the process of running the Python program? Okay, and how to run the Python program. So these are pretty much we will cover today. Okay, so this will be only high level idea. Okay. Okay, guys. So let me start. The first topic is about operating system. Okay. So what do you mean by operating system? Like you might be using in your laptop, maybe you might be using Windows, Mac OS, Linux. You might have heard about this operating system, right? So any idea what is your thought? Why we use operating system in laptop? Let's suppose that there is no operating system, then what will happen? Any thought? Let's suppose I remove. Yeah, go ahead.
We may not able to do our function.
Yeah.
We may not able to access the information.
Yeah, so let's suppose if I remove the operating system from your laptop, so your laptop is just a plastic box. Without operating system, it is zero. Okay, you can do nothing without operating system. The laptop is just a plastic box. You cannot do any task. You cannot perform anything. For example, you want to play video, you can't play video. You want to write some notes, you cannot do anything. So pretty much you cannot do anything. Without operating system, you cannot do anything. Okay. So what happens, can you see my whiteboard? I'm sharing one whiteboard. It is visible?
Yes.
Yes, sir.
So let me explain what is operating system and why we require operating system and how it is related with the programming. Okay. So it's a background. So in a system, first we install operating system. Okay. And once we install operating system, then on top of operating system, we install multiple applications. For example, if we want to read PDF, then we install Adobe PDF Reader, right? Let's suppose I want to edit some video, then we install Video Editor. Let's suppose I want to play some media file, maybe some music. So we install VLC player, some media player, right? So if you want to perform any task on top of your laptop, then first of all, you have to install OS, which is very fundamental, which is without OS, you cannot do these all things. You cannot read PDF, you cannot do video editing. Okay. So these all application cannot run without operating system. You have to install OS, only then this all app will work. Otherwise, it's not going to work out. This is very simple, right? And in your laptop, what happens? There are a lot of resources. So this the top one, we call it apps, like PDF reader, video editor, media player. These are apps or applications. Okay. And every laptop or every machine has some resources. We call resources. For example, your camera. So every device, every laptop has some camera. It has some keyboard. From the keyboard, you can type some text. You can give some command. And the important thing is the RAM. In every laptop, every machine, there's a RAM, random access memory, and there's a CPU, and there's a hard disk. Okay, so these are fundamental resources are available inside your laptop, right? I think you might be aware of these all resources. What is RAM? What is CPU? What is hard disk? I'm not going to talk about in the detail what is CPU, what is RAM. I hope you might be knowing these. So these are pretty much called resources. These are your resources and these are your applications. Okay. So why operating system is required? Let's suppose what happens, these resources are limited. Where your RAM, the size of RAM can be 8 GB or whatever, that depends upon your system configuration. So RAM is limited. Okay. Your CPU is limited. Okay. And these are very expensive. So let's suppose you're running multiple applications. At the same time, you are running multiple applications. And you know that we can run multiple applications at the same time. You can open video PDF reader, you can open video editor, you can play music, you can watch YouTube, you can watch Facebook. So you can run multiple tasks at the same time. Okay. So how it is possible that we can run the multiple tasks at the same time? Because of OS. Okay, so let's suppose you're running, let's suppose you're doing video editing. Okay, and you are doing some editing in the video and you are playing some music. Both is happening simultaneously, both is happening at the same time. Okay, so both the applications, they require RAM, they require some memory, they might require some CPU. Okay, so let's imagine there are two persons. Okay, there are two persons and there is just one cook. Okay, suppose RAM is a cook who is cooking some food for you, and there are two persons. Okay, and these two persons are very hungry. Okay, and this cook RAM who's making some chapati. Okay, and these two persons are too hungry and they want chapati, and they both want chapati from this cook. But the cook is limited, right? He has the limited potential, he has limited capacity to produce, to create the chapati. So let's suppose this person A needs 10 chapati. At the same time, person 2 also needs 10 chapati. But this man, the cook, is able to produce only 10 chapati. But there is a requirement for 20 chapati, 10 chapati by person 1, 10 chapati by person 2. But this person cook, which is RAM, it can produce only 10 chapati at a time, right? So here you can see that we need some person to synchronize. We need some person to manage the resources, because cook is one, there is one cook and there are multiple person who looking to chapati. So we need some person, so manager, to manage the request. Okay, otherwise these two persons will start fighting. I need my chapati, I need my chapati, right? They're hungry. So we need some person to manage these all things. So the OS plays an important role. 1 second, guys. Link is same. Link. Okay, let me share the link. Guys, link will remain same. Okay, it's a reoccurrence class, so link will not change. Link will remain same. Okay. Hello, Bala. You joined a bit late.
Hello, sir.
Hello.
Yes, sir.
Okay, guys, let me share my screen. Okay. So Bala, I was talking about the operating system. Okay, why operating system is important in machine, and because before programming, I want to give some introduction. What is operating system? What is RAM? So that's what I'm talking about right now. So every system, every laptop or every computer, that every system has operating system. Okay, and on top of that, we have multiple applications. But our resources are limited. For example, our RAM, our CPU, hard disk, these resources are limited. Okay, but at the same time, there are multiple applications are running on the OS, right? For example, video editor, media player. So let's assume these two are the people who are looking for. I'm giving one. I'm just trying to draw one analogy. Okay, so let's suppose there are two persons, person one, person two, and there is one cook, RAM. RAM is your cook. Okay, and who is creating chapati. And person one needs 10 chapati, and another person, which is media player, that also needs another chapati, 10 chapati. Okay, so there is a requirement for 20 chapatis, 10 chapati by first one, person one, and 10 chapati by another person two. But this man who is cook, he is able to produce only 10 chapati at a time. But there is a requirement for 20 chapati. Okay, because these two apps are running same time, and they might require the RAM, but the RAM is limited. Okay, so who manages all requests? Let's suppose we need some people, we need some person to manage this all request. This person is 10 chapati, this person is again 10 chapati, but this person is only able to produce 10 chapati. So something, we need some manager, some person to manage this all requests, so that there's no battle. So if this request is not properly managed, then these two persons will start fighting. I need chapati, right? So everything will become chaos, everything will become unstable. So for that, operating system play an important role as a resource manager. Okay, so these all requests are handled by the operating system, because our resources are limited, my RAM is limited. So these all actions, these all things are managed by operating system. So it manages the applications, it manages the resources, and it makes sure that all the applications get the fair chance of using RAM and using CPU. Okay, so every people should get the fair chance. It is not the bias कि this application will get more RAM, this application will go more chapati. No, so this person will make sure that everything is managed. So it is like you can say it's kind of your chief minister or kind of prime minister, like that. Okay, so that's the use of operating system. Okay, I hope you are able to understand this concept, this analogy. Any doubt here? What I'm trying to explain here. So OS plays an important role as a resource manager. Let me share again. Okay, so why do we need OS? So OS is an operating system. OS is used to handle the resources in our system. Okay, resources means our RAM, hard disk, CPU. So these are resources. Your memory is resource, CPU, devices, networking. There are so many resources. Okay, so OS is an interface between user, your app, between apps and computer devices. It manages your it is just like a resource manager, or it's an interface which manages all the apps and computer devices. Okay, so that's the purpose of operating system. And apart from this, one more concept I want to talk about is what? Let's talk about Python code. Okay, Python application. Okay, so your Python application is nothing but some app, just like a media player, video editor. It is another app. You can write multiple Python applications. Okay, so your application, whatever app you're developing or you will develop in future, so these applications are running on top of operating system. Okay, all the app will run on top of operating system. And this app requires RAM. Okay, let's suppose you're creating multiple data in your, let's suppose in your application, you have a requirement to load data from Excel sheet, from database, from somewhere, and you're loading a lot of data, billions of record in your Python application. So at the runtime, if you're doing some processing on the data, so that data will sit inside the RAM. Okay, not the hard disk. Hard disk and RAM is different. Hard disk is a kind of permanent storage. If you want to store something permanently, then you have to put in hard disk. But let's suppose you're writing a program, and in the program you're doing some processing at the runtime. When running the program, then your data will sit inside the RAM, not in the hard disk. You got this? So if you're writing a program and you're dealing with data, billions of record, so that data are sitting inside the RAM. And remember, RAM is limited. Okay, there can be chance that let's suppose RAM is 8 GB. I'm giving an example. Okay, RAM, the size of RAM is 8 GB, but the data that you're loading in the application is suppose 20 GB. Okay, so the 20 GB of data cannot be fit inside the RAM, which is with the size is 8 GB, right? It is not possible. So in that case, your program will shut down. Your program will just crash in that case. So you have to use your memory management very properly. So don't worry about that. You don't have to do those management. The operating system and Python will take care of that. So here I'm just trying to give the introduction key. If you're writing Python application, okay, so make sure whatever data you are using in the application, that data at the runtime when your program is running, that data are kept inside the RAM. Okay, so this is the important concept I want to make a note. So within the application, your data will sit inside the RAM, not in the hard disk. Okay, and let's suppose you process something and you want to persist your data. You want to save your data permanently. Okay, then you have to save the data into hard disk. So what happens? Let's suppose you save some data in the RAM and the program gets over, program execution gets over, then all the data from the RAM get cleaned up. Okay, so nothing remains stable in the RAM. So data are available in the RAM during the program. When the program is running, only during that data is available. Once the program is over, everything is got cleaned up. Okay, so yeah, so that's what you have to understand, RAM and hard disk. Any doubt here? What I'm trying to explain here?
No, sir.
Okay. So what is the operating system? Operating system play as a resource manager to handle the resources among all the applications at the same time. Okay, and your applications run inside the RAM. You need a RAM to process your data. Okay, now let me talk about the programming languages. Okay, so why we need programming language? Why we are learning programming language? For example, Python here. Okay. So the purpose of learning language is what? To perform some task. This is the only purpose. For example, let's suppose I have to perform a task that I want to load data from Excel sheet. So let's suppose you have employee data. You have some data about manufacturing product, something user, some record, some employer record in the Excel sheet. Okay. And you want to load the data in the memory in the program from the Excel sheet, and you want to do some processing. Maybe let's suppose there's a data about salary, there's a data about employee, and you want to extract that what is the maximum salary and what is the minimum salary and what is the salary of people who having age more than 20, like that. You can process your data different way. Okay, so for that you have to load the data in the memory in using Python program, and you have to write the logic. So pretty much you have to write a task. Okay, to perform your job, you have to write a task. So for that task, you have to write a program using some programming language. It can be Java, it can be Python, it can be any language. Okay, it can be any language. So only purpose why we are learning programming here, to perform some tasks with the Python. Okay, so that's the purpose of learning programming language. There are two types of programming language. One is called low-level programming language, and one is called high-level programming language. Okay, so what is low-level programming language? Let me explain that. Computer. If you know the computer only understand binary code. Do you know that? There's a binary code, decimal number. So computer only understand binary 0101. Let's suppose you have a decimal number. Let's suppose you have to add two numbers, 7 and 8. Okay, so you have A is equal to 7, B is equal to 8. You want to add two numbers. Okay, so what the machine does, it will convert the 7 into binary and 8 into binary, and then it does the binary operation. So everything is a binary, everything is a 0 1 0 1 in the machine. Okay, so this is called machine code. If you are writing something in the machine in 0101 term, that is called machine language. So language are there are two types of language, where in first language, which is called machine language or low level language, where we're writing the entire code into 0101. Let's suppose I want to add two numbers, I want to print hello world, so everything will do in terms of 0101. Okay, so such language is called low language. Okay, so in the low language programming, we are dealing only with machine language, maybe binary language, maybe 0101. Okay, so or it is also called assembly language. So these kind of language are very difficult to understand, and only very special person who have very strong idea, who have a great knowledge about the binary code, assembly language, only those people can understand, and they can write the low level language. So low level language happens in the terms of 0101. Okay, so all the instruction, for example, adding, subtraction, all the instruction you have to write into 0101 in case of machine level. In case of low level language, it is also called machine language. Okay, so it is very difficult to understand and difficult to write machine level language or low level language. Okay, because there are a lot of challenges in the machine level language. So here we are not going to learn machine language because it's very difficult to understand, difficult to manage such languages, and it is not for common people. Okay, it is not for common person. So for that purpose, because it's very difficult to manage, we have developed high level language. Okay, for example, C language, C++, C#, Java, Python, JS, PHP. So these languages are all called high level language. And what happens in high level languages, the beauty of this language is what we write the instruction in terms of English. Okay, for example, this you can see here, if I write this code like this, A is equal to 7, B is equal to 8, C is equal to A plus B, print C. So any person can understand this piece of code. It's very simple to understand. It is just like an English language, right? So such language where we write English kind of syntax, though it is not pure English, but it is very close to English. Okay, so such language are very easy to understand. Any people, any person from different background, you don't have to you don't have to be very great knowledge in computers or machine language or assembly language. So anyone can learn high level language. So why we have developed high level language? Because it's easy to understand such kind of language, because it's a syntax is kind of English syntax, and it's easy to manage, and any person can understand this kind of language. Okay, so such language is called high level language. Okay, so there are two category, low level and high level. So in low level, we write the syntax in terms of 0101, which is very difficult to understand, very difficult to manage. And in the high level language, we write the code in terms of what? English type of syntax, and where it is very easy to understand. Okay, so this is the example of low level and high level language. Any doubt here in understanding what is low level and high level? Anyone?
Yes, sir. It's clear, sir.
Clear? Okay. So here our intention, our goal is not to learn low level machine level language. Our goal is to learn high level language, maybe only Python. Okay, not the all language. Okay.
Sir, I have one doubt.
Yeah, go ahead.
In case of when we are talking about high level languages, we have so many languages now, C, C++,
Yes.
Java,
Yes.
like that.
Yes.
Then what is the difference? Python is the simplest language, or
yes. See, every language has its own pros and cons. Okay, for example, C, C++, C#, Java, and every language has its own usage. For example, C, C++. Okay, so these languages are used in terms of drivers. Like, for example, you want to develop some embedded system, or let's suppose some hardware system. Let's suppose your oven or your freeze, like of that. Okay, so let's suppose your driver, your computer drivers. Okay, so there we use C, C++. And Java is used mainly for web application. For example, your banking applications, your insurance applications. So there Java is pretty much is a leader. Okay. And Python are used in terms of data, because it sits very good in with data, where you have to manage data, data management, data science. So in the data science field, Python is the leader. Okay. Java is a leader in the web application, and JS is the leader in the UI front end. Okay, and PHP is a leader in the web application again. Not web application; it's a kind of web development. So every language has its pros and cons. Okay, and it has its own usage, and then can be different learning curve. For example, C++ is a bit difficult language, I would say, but it's I would say it's a mother of all languages. If you learn, let's suppose you know C++, then you can learn all kind of languages, because it's a bit difficult language. It has a lot of complexity. But Python is very simple language as compared to Java, C++. It's very simple language because its syntax are very small. Its syntax are very concise, and its syntax is pretty much like an English kind of syntax. Okay, and it is scripting language. We call it a scripting language. Java is not a scripting language. These are not a scripting language. Okay. So, okay, what happened in scripting language? We call Python a scripting language. So in a scripting language, you don't have to write a lot of logics. It's very in the layman term. If I define what is scripting language, it is just like an English syntax, just an English command. Okay. For example, you want to let's suppose you want to print some data, then say print my data. That's all. But in case of Java, it is not so straightforward. Okay, so scripting languages are very straightforward. You don't have to, there's no much complexity. Okay, so why we're learning Python here? Because Python, this is the industry standard that Python has become the leader in terms of data science, data engineering, because there are a lot of projects are running on Python nowadays in artificial intelligence, machine learning, data side. So that's why it's the industry preferred Python in data field. Okay, and industry preferred Java in the web application. So every language has its own usage on what pros and cons. I hope I'm able to explain you.
Understood, sir.
Okay. Yeah, the syntax are different. Each language has different way of writing the syntax. So syntax will be different, and even the logic is a bit different, but more than 80% logics are same. If you, let's suppose if you learn Java or C, then you can easily learn other language because syntax logic is almost same. Okay, guys. Next topic, I want to talk about the development kit. Okay. So here I explained that what is machine level and what is high level language. Let me go back here, right? So as you know that machine, your laptop only understand machine code. They understand only 0101. Okay. If you give this instruction to machine, ki A is equal to 7, B is equal to 8, C is equal to A plus B, print C. So this instruction machine will not understand because it's a high level. It's a 7, 8. So machine does not work on decimal number. Your machine, your CPU understand only 0101. Okay. So this is called machine code or machine language. Okay. So this piece of code is called high level language, and machine code, which are only 0101 binary, that is called machine code or machine language. Okay. So here, let's suppose I want to run high level language. For example, in Python. Okay. Python is a high level language. So let's suppose I wrote this piece of code in Python. Okay. And I want to see my output. I want to give this instruction to computer to run this. Okay. So this program cannot be understood by your computer because it is not a binary code. It is not a machine code. Okay. So I need somebody, some tool, some software to convert this high level language into low level language, in machine level language. Okay. So somehow I need some conversion. So I need some tool, software to convert this piece of code into 0101. Okay. Because the machine only understands 0101. So that's why we need some converter. Okay, so that's why we need compiler. Okay, so we have a compiler. So so how to convert your high level language into 0101 in Python? Okay, so there are two processes. One is the compiler, one is the interpreter. So let me explain the process, how it works. So you saw that yesterday here, if you're writing any Python code, for example, print hello. Okay, yesterday we saw that, right? Print hello world. So here I just run this icon, this play icon, right? And it just it gives you output, right? It is very simple. It looks very simple, but behind the scene, it has two steps. You're not visible, and these two steps are not visible over here, but it requires two steps to get you output. Okay, whatever output you see here, hello world, it is because of two hidden steps, and these two steps is called compiler and interpreter. Okay, so this is the two process happens whenever you're writing your Python code and you're running it, and you see the output. So between running the writing the code and getting the output, there are two steps. Okay, so first step is called compiler, and second step is called interpreter. Okay, so these are tools. These compilers and interpreters are software. These are tools. Okay, and these tools comes along with the Python. Yesterday we saw that, right? Yesterday we installed Python in the, I think in one of the machine. Remember, you are able to recall? So let me go there. So yesterday we download Python, right? If you say download Python.
Yes.
For Windows, right? So yesterday we saw, I think Sunil, yeah, in your machine. So here you can
Yes,
see
yes.
here, yesterday we downloaded Windows Python. Okay, it's a exe file. Okay.
Okay.
So in this exe file, it has a bundle of, it comes along with what? Compiler and interpreter. Okay, so that exe that you downloaded yesterday from this site, it has already packaged. So these two compiler and interpreter already packaged in that software. You don't have to install separately. It is already there. Okay, so but you have to understand that there is a compiler and interpreter. Okay, so and these are the part of your exe file. So let's assume we have two tools, compiler and interpreter. Okay, so how it works, how it produces a machine code. Okay, so here I'm trying to understand, I'm writing a Python code. It is called source code. Okay, so this code, what you're writing here, this print hello world. So in the technical term, we call it source code. What? Source code. Okay, it is called source code. Okay, and this source code are high level language. For example, print hello, this is high level language, just like an English term. So this source code I need to convert into machine code, because ultimately machine will only understand machine code. Machine will not understand this source code. Okay, this source code is for humans, for us to understand, to give the instruction, but ultimately machine only understand machine code. Okay, so somehow I need to convert this source code into machine code. So how this conversion happens? This conversion happened with the help of two tools, compiler plus interpreter. Okay, and these two tools comes along with the Python. Once you download the Python, this tool are already packaged there. You don't have to download separately. So here the steps. So what you do, first you write a Python code. Okay, for example, print hello world, this is my Python code. So first you have to write a Python code. Okay, and this Python code you have to save as a .py file. I can give you one demo here. If somebody has, but for that I need to install Python. Okay, so whenever you're writing any Python code, you have to any source code, you have to save the file as a .py file. .py is the extension for Python file. Okay, so .py means the Python will understand that this is the Python file. So this is step number one. You write the source code and save the file as a .py file. Okay, then this file is getting compiled. Okay, so there's a command for that. Let me show that. You have to run this command to compile it. Yeah. So this is the command to compile the Python code. Okay, so the Python Python -m, okay, and py underscore compile, okay, and your file name. Suppose my file name is trace.py, okay. So this command you have to run on a command prompt. Okay, so this command is a kind of compiler. So this command is doing what? This command is just calling the compiler, okay, and it is screen. Can you see my screen? It is visible, right?
Yes, sir.
Okay. So here first you write the Python code, okay, then use that command that I showed you, this command, okay, and this command will compile the code into .pyc file. This is called bytecode, okay. So your source code is getting converted into what? Bytecode, .pyc file by compiler. The screen is not visible, okay. Let me reshare them. I think there could be network issue. Can you see my screen now?
Yes, sir.
Okay. So first thing, you're writing the source code. Okay, that is pretty much okay. I save the file as a .py file. Then I run the command, compiler command, and this will compile the file into .pyc file bytecode. This is step number 1. Okay. Again, this pyc file bytecode, it is not a machine code. It is very close to machine code, but it is not 100% machine code. Okay. So again, this pyc file again needs to be converted into machine code. So who does that? Interpreter. Okay. So Python has interpreter. Any questions, Sunil?
Screen is not visible, sir.
Screen is not visible.
Screen is not visible to me. Yes.
I think for other people
visible,
it is
sir.
visible, right? Can you confirm other
Sir,
people?
Yeah, it is visible for me.
It is
even me
visible,
too.
Sunil.
Okay.
You just rejoin, Sunil. Just stop and rejoin. Sometimes what happens because of
Even-
network issue, your network will be not stable. So sometimes you lost it. So rejoin. Okay. Okay. So compiler does not produce machine code in Python. It produces what? Bytecode. .pyc file. Okay. And these bytecode are given to interpreter. Okay. And then this interpreter take the bytecode and this produce the machine code. So how to call interpreter? So for that, this is the command, Python test.pyc. Okay. So you have to use 2 commands, one for compile, Python -m py underscore compile, and your Python source code. This is the source code. Okay. So this command, if you run this command, it will produce bytecode, test.pyc file. Okay. Then compiler will take this bytecode and you have to run the compiler interpreter. So Python and your bytecode name, test.pyc file. Okay. So this command ultimately produce the machine code like this. So in Python, there are 2 steps. Okay. How many? 2 steps. First, the compilation step, and second is the interpreter step. Okay. So there are 2 steps happens behind the scene, and ultimately your machine codes get produced and the machine is able to run your instruction, whatever you write in source code, and you will see the output. Okay. So these 2 steps are happening over here in the Google Colab notebook. If you're writing these things, so whatever I explained over here, your compiler interpretation. Okay. So these 2 steps are happening behind the scene over here. Though you're not visible, it is not showing up. So what happens if I run this? Okay. If I run this, so on the fly, it happens. Okay. You're getting this? On the fly, it happens. It is so fast that you're not able to visualize, you're not able to feel it, but it happens behind the scene. You're getting this? So there are 2 steps for running the Python program. Any doubt so far? We are good?
Sir,
Yes. Yeah, Ganesh?
sir, hello world is our source code, right, sir?
Yeah, this is my source code. Yes. Hello world. This code is this is my source code. This is source code. Yes.
Source code.
Yeah, this
To
is
run
source code.
that, compiler and interpreter will run.
Yeah, to run this, you need compiler plus interpreter. Okay.
Yes.
But what is happening over here? If you're running this, then actually both is happening, okay? Behind the scene, it is getting compiled, it is getting interpreted. It is happening behind the scene. You are not doing manually, okay? Though you can do manually, okay? You can run this command manually. These two command, you can, if you want to fill it, if you want to experience it, you can do it, okay? But for that, you have to install Python in a local machine. Okay. Here I have not installed anything locally, everything is online. So if you run this button, what happens? It is doing actually basically both. Okay. It is calling compiler, it is calling interpreter, it is happening behind the scene. And it is so fast that it is not visible for you. But it is happening. If you run this icon, it is happening. It is getting compiled, it is getting interpreted on the fly. It is happening on the fly. It is happening. Okay. So if you want to fill it, if you want to experiment it, then you have to install Python in your local machine. And you have to call compiler, then you have to call interpreter. And how to compile this, I have shared the code for that. Okay. So you have to run this to command on a command prompt, then you can fill it. Okay. So this is the step. So you have to write a file, source code, then you compile it, then interpret it. Okay. Then you will see the output, final output. Okay. But these two processes happen so fast that you will not feel it. It is happening. But behind the scene, it happened. For example, here, okay, it is so fast, it does not appear that it is happening, but it is happening behind the scene. Got it? Because
So
nobody,
what-
yes. Yeah, Ganesh?
So what is it? Interpreter PVM.
Okay, so interpreter, what the interpreter is kind of, it is called Python virtual machine. Okay, it has two names. We call it interpreter or we call it Python virtual machine. I will talk about it, okay? It got two names. You can call either interpreter or you can call it as a PVM, Python virtual machine. Python virtual machine. Okay, PVM. Okay.
PYC is Python code.
Python virtual machine.
PYC is Python code, no, sir?
Your voice is breaking. Can you put in chat box what are you asking?
PYC.
దానికి ఏం వచ్చాను కట్టి
Sir,
ఉండు గంట కొడుతుంది
Sir,
Can you?
PYC is Python code, right, sir?
No,
PYC
PYC
is
no.
Python code.
No. PYC is not a Python code. It's a byte code. Okay. Python code is the source code. Okay. You're writing the source code. So first source code gets converted into byte code. It is very close to machine language. Okay. The byte code is very close to, it is very similar to machine code, but it is not exactly 100% machine code, but it is very close to machine code. Okay. And only interpreter, only PVM will understand this byte code and it will produce the machine code.
Oh,
Okay. But these are two steps happen behind the scene. Okay. So here PVM play a very important role. Okay. This interpreter, Python virtual machine, it plays very important role. So what happens? So this is the structure you have to remember. Okay. So whenever you're writing any Python code and you're running the Python code, so what happens? So let me explain this picture. So first of all, you have a operating system. Okay. In your laptop, you have to install operating system first. I have already explained why we require OS. Okay. In the beginning. So let's assume you have operating system. Okay. It can be Windows, it can be Linux, it can be Mac, it can be Solaris, it can be different kind of operating system. Okay. And on this operating system, you have to install Python, right? Yesterday we saw that, right? Let's assume you have a Windows system. Then you have to install Python for what? For Windows. Let's suppose you have Linux system. Then you have to install Python for what? Linux. So for every operating system, Pythons are different, right? Yesterday I explained you, right? Here you can see the Python. So here I'm downloading the Python for what? Windows. So for Windows, it is different. For Mac, it is different. For Linux, it's different. So every operating system had its own Python. Are you getting this?
yes, sir.
So the Python software is a machine dependent. Make a note. The Python software is a machine dependent. Okay. So here, because you are downloading the Python for a specific window, a specific operating system. So it's a machine dependent. So if Python, the tool, the software, for example, compiler, interpreter, Python, that depends upon the operating system. Okay. So let's assume that I have a Windows system. So for Windows, I install my Python. So in the Python, once you install the exe file, so it contains the PVM. It contains the Python virtual machine inside it. Okay. So once you install the Python, it will come automatically. You don't have to do manual setup. It will come automatically inside the Python tool, Python software. So this is your Python virtual machine. Okay. And if you're writing the Python code, so your Python code basically running in the PVM. So this is the hierarchy. Okay. At the bottom, you have operating system. On the top of OS, you have installed Python, or you have installed PVM, which is a Python virtual machine, and you're writing the Python code, Python app, okay? So source code. So your Python application are running in the PVM, inside the PVM, okay? So there is a layer between your Python application and OS, there is an intermediate layer, which is called PVM, Python virtual machine, okay? So this plays an important role. How this plays an important role, let me explain that. So this picture is clear to everyone. This setup is clear. What I'm trying to explain here.
Yes, sir.
Okay. So how PVM play important role? See, there's a concept that your software, the Python software or PVM is a machine dependent, right? This is a statement. You just make a you can make a note of this statement. So Python tools software is a machine dependent, but the Python application that you're writing, that is machine independent. Okay. So this is very concept. Let me go to the concept. So here I want to explain one concept here. Okay, so this is a process. You write a source code, you compile it, it produces a bytecode, then you interpret it, PVM, then it produces a machine code. Okay, so this is steps I've written here. Where is that concept? So this is one concept. Python is a machine independent language. Okay. And this is a very hot question in any interview. They ask that how Python is a machine independent language. This is the concept. Okay, so let me explain this concept very quickly. So here are two concepts. First is Python tools. Okay, Python software is a machine what? Dependent or independent?
Dependent.
Dependent. Okay, the software itself is a machine dependent, but the Python language is a machine independent. Okay, so how it happens? Let me explain that concept. Okay, so the concept is Python is a platform independent. Okay, if I say that Python is a machine platform independent or machine independent, what does this mean? It means that the bytecode can be moved to different platform. Okay, let me explain that. Let me give us an example. Let's assume we have three systems. Okay, one has Windows operating system, second has Linux, third is Mac. I'm giving three examples. Okay, and for each operating system, I have installed my Python. Okay, you know that Python is a machine dependent, right? Your PVM compiler software is a machine dependent. So let's assume for Windows, I install PVM, I install Python for Windows. For Linux, I install PVM, I install Python for Linux. And for Mac, I install PVM or compiler. Okay, so this PVM is a machine dependent. Okay, this PVM is for Windows, this PVM is for Linux, and this PVM is for Mac. Any doubt so far? This part is clear? So PVM is machine dependent. Okay. Okay, now let's suppose one person on this window, they install the PVM, okay, and they are writing the code. They're writing the source code, Python code, okay, and they compile the code on window, okay. So after compilation, it will produce what? Bytecode, right? Another bytecode. So let's suppose in the window, I produce bytecode after compilation, okay. Now this bytecode, which are produced on window, I can take this bytecode from here, from window, I can go to Linux, okay, and I can run the same code. Or I can take this bytecode from here. I can go to Mac OS and I can run this. It will produce, it will give the output. Okay. So here you can see I don't have to change the bytecode. Okay. The same bytecode I just produce the bytecode on Windows system, and same bytecode I can move to different platform. And this without any change, without any modification in the bytecode, it can run on the Linux, it can run on the Mac. So that's why it is called machine independent. Okay, so it has nothing to bother about the machine, on what machine you're running the bytecode. Irrespective of machine, it will produce the same output. Whether it's a Linux or Mac, it will give the same output. Okay, so this phenomena is called machine independent. So why it is happening? Why it is possible? Because of PBM. Okay, what happens? Let's suppose on Windows you produce the bytecode, you went to Linux, and let's suppose there is a PBM already installed for Linux. Okay, so what this PBM build does? What is the purpose of PBM? PBM produce the machine code, right? The purpose of PBM is machine code. So here on the Linux, this bytecode, let's suppose I'm running the bytecode in the PBM, which are on Linux. So this PBM, which are for Linux, this will produce the machine code for Linux. Okay, so how it is possible? Because of PBM. So PBM playing a very important role. Let's suppose PBM, let's suppose for time, let's suppose there is no PBM. Okay, there is no concept of PBM. So let's suppose I produce a bytecode. Okay, so this bytecode, in the absence of PBM, this will not run on Linux. It is not possible. It will not produce machine code. So in order to produce machine code for Linux, I need a PBM for Linux. Okay, now this bytecode will get produced into machine code, and it will run you will see the output for Linux. Okay, so the machine code generation is happen with the PBM. Now same bytecode I can go to Linux, Mac, and I can produce it. Okay, are you getting this? So that's why it is called Python is a platform independent because of PBM, only because of PBM. And the PBM itself is a machine dependent. Okay, PBM is a machine dependent, but the Python code is a machine independent. It's a beauty. Okay, this is possible only because of PBM and the bytecode. So bytecode we can move. Okay, got this? Any doubt here? Anyone?
One time, please. Hi,
Yes,
sir. This Python is independent of
Python is Python is a machine dependent. Okay, Python tools.
Okay.
Tools. I'm saying the tool exe file. There, for example, compiler, interpreter, PBM. The tools. I'm talking about the tools. The Python tools. Python tools is a machine dependent. So you have to install Python for its own system. For example, Windows, Linux, you have to install Python. But once you're writing the code, source code, okay, that is machine independent.
Okay.
So suppose like Ganesh has Windows and you have Linux. Okay. So Ganesh will write some Python code. Okay. He will produce bytecode, and this bytecode Ganesh will transfer to you in your machine. Linux machine. Okay. And the same bytecode can be run on your machine, Linux machine, without any change.
Okay.
You getting this? So only Ganesh will transfer the bytecode, same bytecodes which were produced on Windows, and same bytecode will work on the Linux without any change. But condition is what? You have to install PBM on your Linux. Only then it is possible. Got it? So this is called machine independent. So Python is a machine independent, but the Python tool is a machine dependent. You got this concept? A lot of people get confused here.
Python tool is
machine dependent.
Yes,
Python tool.
Tool software like exe file, like compiler, interpreter, those are machine dependent. Okay, but the Python language, it's a machine independent or platform independent. Clear?
Okay.
Okay, guys. So yeah, so this is all about compiler interpreter and how because nobody has installed the Python, I need a laptop. Okay, I need a laptop only, then I can give some demo. So here I give so these are the syntax, okay, to compile and interpret. So on the Google Colab notebook, you don't have to run these two code manually. First you compile and interpret, you don't have to do manually. Okay, it happens on the fly. You have to assume
Okay.
it is happening. Okay, but you want to experiment these two commands, then you have to install Python in your machine. Then you can perform these two actions. Then you can feel it. It is happening. It is getting compiled. It is getting interpreted. You will feel it. Okay. So in today's session, we understand what is compiler, what is interpreted, what is high level, what is low level, and why we need compiler. Okay, and how Python is a machine independent language. Okay, so this is pretty much high level of about programming. Not program. It is about introduction. So the real programming will start from tomorrow. Okay, the programming component.